Today I was hoping we could talk about one of your very favorite topics in the world.
Star Wars?
No.
Organic beets?
No.
Underwater basket weaving?
Still no. I'm a fan of free-range vegetables too, but I was thinking more hydraulic fluids for today's topic.
Oh, right. Well, I guess hydraulic fluids are probably up there as well.
Great. So there's a lot to say about hydraulic fluids, so I think we should probably make this a two-part video. But let's start with the basics. So hydraulic fluid has several different purposes, right?
Right.
The primary purpose, of course, is to transmit hydraulic energy in the combined form of both pressure and flow.
Yes. For simplicity's sake, hydraulic fluid can be considered solid and nearly incompressible, as it acts upon pistons of cylinders, as well as gears, pistons, and vanes of motors.
Sure.
The hydraulic pump pushes on the fluid, and the fluid pushes on the actuators. This is the easily understood nature of fluid in a hydraulic system. However, transmission of mechanical force is not the only trick in its bag. Contamination removal, heat transfer, sealing, and lubrication are all important secondary properties of hydraulic fluid. Although these properties are innately functional within hydraulic oil, considering them as a part of the design or maintenance of mobile machinery will help you get the most out of your system.
Makes sense.
Contamination removal in hydraulic fluid is the most commonly considered of the secondary properties. Everyone knows dirt needs removed from hydraulic oil, which is why every mobile machine has at least one hydraulic filter on it. Typically a poor quality one, which is something your father never told you about hydraulics. Although estimates vary, everyone agrees contamination is the #1 cause of failure of pumps, valves, actuators on mobile equipment, even ahead of physical damage. Hydraulic fluid helps control contamination pretty much by default because it circulates through every component that you're trying to protect. As contamination is either externally or internally generated, it will be picked up in the fluid stream and carried back to where it can be trapped by the filters. We can ensure we take advantage of these particle transportation properties of the fluid by trapping as much as possible in strategic locations. I recommend high quality return filters on the return line, as well as a pressure filter mounted after the pump. Because pumps are a common failure point, their degradation will not result in more contamination being transmitted to the rest of the hydraulic system when a pressure filter is installed. Heat transfers efficiently through a liquid, making an excellent tool for convection of thermal energy. Anywhere in a hydraulic system where hydraulic energy is not being used to create useful work, the byproduct is heat. The major heat generators are pumps, motors, and relief valves, and because heat reduces the viscosity of fluid, it needs to be carried away from the components and cooled if it reaches high temperatures.
Makes sense.
Although the fluid carries heat with it by default, just as with contamination, you must take advantage by sizing reservoirs appropriately and by adding cooler when heat generation is high.
So you haven't really touched on sealing too much yet.
Well, sealing between static components is almost exclusively handled by soft seals, such as O-rings. Dynamic sealing is also mostly with the soft mechanical seals, but not only does hydraulic fluid aid in sealing, it can also be the seal medium itself. Lip seals, for example, use the pressure of the fluid to push against the lips against the sealed surface, further enhancing the sealing efficiency. However, because of a hydraulic oil's resistance to shearing, the oil itself is used as to seal close tolerance in moving bodies, such as the spool of a housing and a directional valve, or the piston and cylinder block of a pump.
Okay.
By ensuring your hydraulic fluid is in its most effective viscosity range, you also ensure the fluid will properly seal in these components. And then lubrication is probably the second most important quality of hydraulic fluid. It enables all of the components internal of the pumps, motors, valves, and cylinders to move against each other efficiently and reliably. If your hydraulic fluid loses its lubricity, such as with overheating or excessive water saturation, component damage is not far behind. Most mobile hydraulic systems use oil, which has natural lubrication qualities, but when applying less common fluids such as Arctic or bio oils, ensure their additive packages provide excellent lubricity.
Great. Well, next time we'll talk a little bit more in depth about fluids, including types of hydraulic oil. Thanks, Josh. Check out all our videos online at www.fluidpowerworld.com.